This lecture video is about operations with complex numbers, and so we're going to learn how to add, subtract, multiply, and divide them, and also raise I to powers. So again, a complex number, by definition, the square root of -1 is equal to I, and this gives us that I squared is equal to -1. And again, complex numbers can be written in the form a plus bi, where a and b are both real numbers and b is not equal to 0. Something else that I haven't talked about yet is if you just have a number in the form bi, this is called a pure imaginary number. So a is called the real part, and the bi is the imaginary part. And so together, the real part plus the imaginary part make up a complex number. So something that we'll need, and we've talked a little bit about this before, is conjugates, and this time it's complex conjugates, but they work the same way as the conjugates did when we were rationalizing denominators and numerators. If you have a plus bi, then a minus bi is the conjugate, and also a minus bi, the conjugate of that is a plus bi. So basically it's whatever complex number you have, you just change the sign in between the two. And steps for performing operations with complex numbers: again, rewrite any negative numbers that are underneath square roots as a complex number. So you would basically take the negative sign out from underneath the square root and it becomes an I out in front of the square root. And then you perform operations treating I just like it's a variable. And at the end you would replace any I squareds with -1. So at first we're going to be adding and subtracting. So again, you just treat I just like it's a variable. And so the quantity 3 minus 5i plus the quantity 2 plus 4i, so we're going to treat I just like it were a variable. And so we would take 3 plus 2, that would give us 5. And then we have -5i and positive 4i, so that gives me -1i. And you can just write that as I, so 5 minus I. In our next example, 8 minus I minus 2 minus 3i. So again, we're treating the I just like it's a variable. So if I were a variable, we would distribute this negative sign. And that gives us 8 minus I minus 2 plus 3i. And then combining like terms, 8 minus 2 is 6. And -1 plus 3i is plus 2i. In example C, 7 minus 9 plus 3i, so again, distribute the negative sign, giving us 7 minus 9 minus 3i. 7 minus 9 is -2, so we get -2 minus 3i. In our next example, -3i times 5i. So -3 times 5 is -15, and I times I is I squared. And remember, any I squareds that we end up with, we replace with -1. So this is -15 times -1, which is positive 15. (2i) times 4 minus 9i, so we're going to distribute the 2i. That gives us 8i minus 18i squared. And replace the I squared with -1, so we get 8i minus 18 times -1. And -18 times -1 is positive 18, so we have 18 plus 8i. In our next example, 2 plus I times 1 plus 4i. So again, we're treating I just like it was a variable, and so if I were a variable, we would do FOIL here, and so we're going to do that. 2 times 1 gives us 2, and 2 times 4i gives us plus 8i. And I times 1 is plus I, and then I times 4i is plus 4i squared. Combining our like terms, we have 2 plus, and in the middle we have 8i plus I, so that's 9i. And then replace I squared with negative 1, so that's 4 times negative 1 at the end there. So we have 2 plus 9i minus 4, and 2 minus 4 is negative 2, so we have negative 2 plus 9i. In our next example, square root of 2 minus 2i times the square root of 2 plus 2i. So again, we're going to do FOIL. Square root of 2 times the square root of 2 is 2. Square root of 2 times 2i is plus 2i square root of 2. And negative 2i square root of 2. And then negative 2i times positive 2i is negative 4i squared. So we have negative 2i squared root of 2 and positive 2i squared root of 2 in the middle, so those cancel and give us 0. And we have 2, and then I squared is negative 1, so we have negative 4 times negative 1, which is 2 plus 4, and so we get 6. In this next example, we have 3 minus 2i, that quantity squared. So remember, this is really 3 minus 2i times 3 minus 2i, so we have to do FOIL. So 3 times 3 gives us 9, and 3 times negative 2i gives us negative 6i, and negative 2i times 3 gives us another negative 6i, and negative 2i times negative 2i is positive 4i squared. So we have 9. In the middle we have negative 6i and negative 6i, so that's negative 12i. And here we have 4 times negative 1. So we have 9 minus 12i, and then minus 4. And 9 minus 4 is 5, so we have 5 minus 12i. Our next example is division, 3 divided by 7i, and so when we divide, basically, we don't really do division, we actually do something that's similar to rationalizing a denominator. And so we basically want to get this I out of our denominator, and so when you just have 3 divided by, and then a pure imaginary number like this, 7i, you can multiply both the top and the bottom by I, and that will get rid of the I in the denominator. So on the top we would have 3i, and on the bottom we have 7i squared, but I squared is equal to negative 1, so this is 3i over negative 7, or you could write that as negative 3i over 7. Okay, our next example here, 6 over 2 plus 3i, so again, this is like when we rationalize the denominator, so we want to multiply by the conjugate, and the conjugate is just the denominator, only change the sign in the middle, so that would be 2 minus 3i. And so on the top, again, I'm going to leave it factored for right now, 2 times the quantity 2 minus 3i, just in case what I get in the denominator will cancel with that 6. And so to get our denominator, we're going to need to do FOIL. 2 times 2 gives you 4, and 2 times negative 3i gives you negative 6i, and positive 3i times 2 gives you plus 6i, and then 3i times negative 3i is negative 9i squared. So we have 6 times the quantity 2 minus 3i on the top, and on the bottom, the middle two terms cancel out and give you 0, and remember, I squared is equal to negative 1, so this is really a plus 9 here. So we have 4 plus 9, which is 13. And so nothing's going to cancel, so now I want to distribute that 6, giving me 12 minus 18i divided by 13. And we need to write this in the form a plus bi. So we need to take 12 over 13 minus 18 over 13i. In our next example, we have 3 plus 2i over 4 minus 3i. So again, I want to multiply by the complex conjugate of the denominator. And so that's going to be 4 plus 3i. And this time I'm just going to multiply right away because I don't have a plain old number that might cancel with something. So I'm going to do my FOIL right away on the top. 3 times 4 is 12. 3 times 3i is plus 9i. And 2i times 4 is plus 8i. And 2i times 3i is plus 6i squared. And in the denominator, do FOIL. 4 times 4 is 16. 4 times 3i is plus 12i. Negative 3i times 4 is negative 12i. And negative 3i times 3i is negative 9i squared. So on the top I have 12, and then we can combine these two terms in the middle. That's plus 17i. And then I squared is equal to negative 1, so that's really minus 6. And on the bottom, the 12i and the negative 12i cancel in the middle, and this is really plus 9. So I have 16 plus 9, which is 25. And that's really a minus 6. So 12 minus 6 is 6, and then plus 17i, and then it's divided by 25. And again, we want it in the form a plus bi. And so we have 6 25ths plus 17 25ths I. The next examples, we're going to look at powers of I. So we already looked at the fact that I is equal to the square root of negative 1. And then when we square both sides of this, we get I squared equals negative 1. And so if I multiply both sides of this by I, then I get I cubed over here. And negative 1 times I is negative I. So I cubed is equal to negative 1. And if you do the same thing, multiply I cubed equals negative 1 by an I on both sides, then you would get I to the 4th. And so I to the 4th is equal to negative I squared. And since I squared is negative 1, I to the 4th is 1. Doing the same thing, I to the 4th equals 1. Multiply both sides by I, we would get I to the 5th. And so I to the 5th is equal to I. And you can just keep on doing that. Multiply both sides of I to the 5th equals I by I. And yet that gives you I to the 6th, and it's equal to I squared, which is negative 1. So the key to finding bigger powers of I, like I to the 27th, is this one right here. I to the 4th is equal to 1. So what we want to do is we want to write this as I raised to some power, and we want the power that goes in here to be a multiple of 4. And then I times the remainder here. So if this is a multiple of 4, then this whole thing will just be equal to 1. Okay, so basically what we're going to do is we're going to take our exponent, 27, and divide it by 4. And 4 goes into 27 6 times. 6 times 4 is 24, and so we would have 3 left over. So we would write it as 3 cubed, and then we could write this as I to the 4th, and then raise that to the 6th power. That would be I to the 24th. And so I to the 4th is 1, and 1 raised to any power is just 1. And so I to the 27th is the same as I cubed, and I cubed was equal to negative I. So I to the 27th is equal to negative I. And negative 2i to the fifth. So negative 2 to the fifth is negative 2 times negative 2 times negative 2 5 times, which is negative 32. And then we would have I to the fifth. And I to the fourth is equal to 1, and so this would be the same as negative 32i. Whoops, I forgot my 2. So you really won't have any problems on this. I just think it's good for you to see what happens when you do powers, bigger powers of I. So basically, if you have a really big power of I, like I raised to the 122nd, then this is going to be equal to I raised to whatever the remainder is when you divide 122 by 4. So divide 122 by 4. 4 goes into 12 3 times, and it's equal to 12, so you get 0. Bring down the 2, and 4 doesn't go into 2 at all, and so we get a remainder of 2. And so I to the 22nd would be equal to I squared, which is negative 1. So again, basically you take this exponent, divide it by 4, and whatever the remainder is, that would be what power of I this whole thing would be equal to. That's it for this lecture. Let me know if you have any questions. Thanks.